Swayam Prabha. Digital India. Educated India.
Hello everyone, we are going to discuss about this course Rock Engineering, and I am Preeti Maheshwari from Department of Civil Engineering IIT Roorkee. So first of all, let us see that why do we need to study this subject rock engineering. As you know that these days lot of infrastructure development is taking place, and especially in the Himalayan region where a lot of hydropower projects are coming up, and you must have heard about the railway line that is being laid between Rishikesh and Karnaprayag. Likewise, you can think about the Konkan railways and many other such projects you must have heard about. Most of these cases, the founding material is rocks, not the soil. So, it is very important as a geotechnical engineer for us to know about this material and to know the branch of engineering which deals with this material called rock engineering. Okay, so we will be discussing various aspects related to this material in this course rock engineering, and it is very important as a geotechnical engineer for us to know the engineering associated with this natural occurring material which is rock, which is very much different than that of the soil and of concrete. So in today's lecture what we are going to discuss is that what all are going to be the topics that we are going to take up. I will be discussing, sharing with you the course material, the references, and then we will start with the introduction part. So let us see that what all are the topics which we are going to cover. So the first one include the rock formation. In this one we will discuss about various rock forming minerals, how we can identify those minerals, what all are the geological classification of various types of rocks, then various geological structures that include faults, folds and joints. Okay, so that will constitute the first lecture. Coming to the next one, that after this rock formation we will discuss about the stereographic projection of the geological data. Now why it is required, how it is done, all these things will be discussed in this chapter. So some of the components that we will be discussing will be principle of equal area net, then how we represent a line which is there in three-dimensional situation, how we represent it in 2D form, so that we will discuss. Then how do we represent a plane, that will be there. Then intersection of the two planes and other applications like where we are going to need these stereographic projection of the geological data. So all those things will be discussed in this chapter. Then after that the third chapter will include lab testing of the rocks. So in this one first we will learn about the determination of the physical properties. Then we will see that how this unconfined compressive strength of the rock is obtained using unconfined compression test. As against soil, this material rock possesses some tensile strength. So how to determine those tensile strength properties, that we will discuss. Then followed by some of the shear tests, that would include oblique shear test, triaxial tests, and then how do we determine the degree of weathering, that can be determined using slag durability test. So that also would be discussed. And then when we conduct these tests, what we are going to get is the stress strain response for any particular type of rock. So, we will learn that how to analyze those stress strain response of the rocks in this chapter. Once we are done with this, and then we will move to engineering classification of rocks and rock masses. I will introduce you that what is the difference between rock and rock masses before that, and then we will have the classification system for the intact rock, that is D. Ray and Miller classification. Then we will learn something about the rock mass, and then some of the classification systems related to rock mass, that is rock quality designation RQD, rock mass rating RMR, rock mass quality, that is Q system, then geological strength index system, that is GSI, and then we will see what are the application of these classification systems in various civil engineering projects. Then we will learn about the strength criteria for rocks and rock masses, and in that one we will learn about the Moore failure theory, then followed by Moore Coulomb criterion, then Hook and Brown criteria, and finally the Barton's theory, which is there for the jointed rocks. After this, then we will go to various aspects related to tunneling. Now, depending upon which area that you have the project related to this tunneling, you can have different ground conditions. So, we will learn about different ground conditions for tunneling. Then the stereographic projections, which we learnt in the second chapter, the application of that we will see here with respect to tunneling. Then elastic analysis of the tunnels under uniaxial, biaxial and hydrostatic conditions, and when we excavate, tunnels are to be provided with lining. So, here in the scope of this course, we will discuss about the concrete lining, and we will study elastic analysis as well as the elastoplastic analysis, and for elastoplastic analysis, we will take up Tresca criterion. And then we will discuss about the rock mass tunnel support interaction, followed by design of the various support systems, like it can be shotcrete, it can be concrete lining, it can be rock bolts, it can be anything. So, all those things we will discuss in this chapter. Now, the next chapter will deal with the problems or the analysis related with the slopes which are there in case of the rocks or rock masses. So, we will first learn about what all are the various modes of failure. Then we will see various limit equilibrium approaches towards the analysis of rock slope stability. Obviously, then as it says, stereographic projections and its application in the area of slope stability, that we will see, and then if the slope is failing, what can be the remedial measure which can be adopted. So, that also we will discuss in brief. And finally, we will discuss about the foundations on weak rocks. You all know that in case of soil, you have Terzaghis bearing capacity theory, but that does not work here in case of the rocks. So, we will learn about the Bell's approach. Then this bearing capacity, which is based on various classification approaches which we have seen, RMR, Q, etc., all those systems based on UCS, based on the plate load test results, and some special consideration and some aspects related to dam foundations that we will be discussing. So, you must have got the idea that in this course we are going to cover almost all the aspects related to analysis and design of rocks and rock masses with respect to various structures, whether it is tunnel, whether it is slopes, or whether it is the foundation. So, the first portion will be dealing with the learning about this material, and then we will see some of the application aspects in 6th, 7th and 8th chapter. Now, the source material for this course is going to be some of the relevant chapters from the textbook on rock engineering. I will be telling you about these textbooks. Then we will have relevant IS codes, then documents which are available in public domain. And in order to make you understand some of the aspects, many images through public domain search have been used, and they would be greatly acknowledged in due course of this subject. Now, some of the books I have listed here, so you can just take a look. This is by Goodman. So, it is overall, it gives you the idea about the introduction to rock mechanics. Then the book by Hook and Bray, it basically deals with rock slope engineering. Then Hook and Brown's book, this deals with mainly the tunneling aspects, that is underground excavations. Then the fourth one is by Jaeger et al. That is again overall rock mechanics textbook. Then the one by Ramamurthy, and then Singh and Goel. So, this one we will discuss with respect to the rock mass classification systems. And then finally, we have others that is rock mechanics and introduction, and this one will be with respect to rock slope engineering. Now, let us start with this introduction. So, first of all, let us understand what is this material rock is. So, basically it is hard, compact and natural occurring earth material which is composed of one or more than one mineral. Now, how one rock is going to be different from the other, that will depend upon its mineralogical composition. Okay? So, that is how we overall manner that we define the material rock. Now, the next term which is very important for us to understand is engineering geology. So, this deals with the application of geological fundamentals to the engineering practices. So, the branch which deals with such type of thing, we put it under engineering geology. Then the next step is going to be rock mechanics. So, this branch, it concerns with the study of response of rock to an applied disturbance, and that applied disturbance can be by any natural agency or it can be by human, because depending upon what are the various engineering processes that are taking place. Accordingly, this branch of rock mechanics will deal with such type of things. Then finally comes our subject, which is the rock engineering. So, you see, whatever is the knowledge that we gain from engineering geology and rock mechanics, that we will apply, and we will learn how to apply those in the various field condition. Maybe it is related to tunneling, it is related to slope stability problems, it is related to foundation on weak rocks in an economic way. So, that is what we are going to learn in this course. Now, coming to this, so basically this rocks, it is a geological material which is granular, it can be heterogeneous and anisotropic, and it is consisting of two components. One is the mineral grain and second is glue. Now, these mineral grains can be crystalline in nature, and when I say crystalline in nature, they can be polycrystalline or it can be amorphous. When we talk about this glue material, it can be rich in iron, rich in calcium, rich in magnesium or rich in silica. And when these two, that is mineral grain and glue, they develop some kind of bonding. Now, this bonding can be mechanical, it can be atomic, it can be ionic or it can be molecular, and these bonding can exist within mineral grain, it can be within glue or at every interface of bonding. Then the resulting material which is called is rock. Okay. So, this is what is an overall basics behind this material rock. Now, coming to the one step ahead, that is rock mass. So, when this rock has various discontinuities, okay. Now, these discontinuities can be in the form of micro cracks, fissures or voids. They can be in terms of joints, it can be geological faults, can be shear zones or thrust zones. Then we call that as rock mass. Please remember that rock with the presence of various discontinuities is called as rock mass. Now you know this, you come across this rock mass every other day in the form of sugar cube. So you see that here I have just put a picture where these sugar cubes are there. So the smallest size of the block of the rock mass is represented by this sugar cube. Now you know how the composition of this material rock is different than that of the soil or concrete, and therefore mechanical behavior of rock and rock masses, they are entirely different than these of soil or concrete. Now let us see field applications, although I have discussed, but let us see them one by one. So let us say one has to go for the construction of large dam. It is to be founded on this type of rock mass which has these set of discontinuities. These continuities will give rise to anisotropy, which will not have the same property in different direction, and therefore we need to know what all are these discontinuities, what is this rock mass, whether they are oriented in the favorable direction or not towards that, because you see the weight of the dam will come into picture. You see on the upstream side this weight, the water pressure will also come into picture. So this dam foundation should be good enough to support all these forces which will be coming to the dam body and therefore transferred to this rock or the foundation material. Then the second one is landslides. Everybody knows this. Okay, rainfall is occurring, and then what will happen? This mass here will start sliding in this direction, you see. So this slope will no more be stable. And then what will happen? Let us say the water that seeps in, it will try to go out from here. Further, it will make this portion slide. Okay. So until unless we know the shear strength behavior of this material, we will not be able to analyze this. Okay. So therefore, it is very important for us to know about this material rock or rock mass. Then the next one, bridges. You can see here there is a foundation, an anchor block, okay, and then discontinuities are there which have been shown by this arrow, and until unless we know the orientation, what is the type of the rock, etc., I cannot go ahead with the proper design of these foundation or anchor block or abutment for bridges. Okay. So in case of bridges, it is equally important for us to know about this subject, that is rock engineering. Then come to tunnels. Let us say this is a rock mass. This complete rectangular portion is rock mass, and in situ stresses, they are acting in the vertical direction, it is sigma V, and in the horizontal direction it is sigma H. Now I make an excavation here. So what will happen when I make the excavation? This free surface here, the stresses are going to be released. Okay, and when the stresses are going to be released, what will happen? There is going to be redistribution in the neighboring rock mass. Okay, and that can cause the differential stresses. Therefore, we need to know what all are these stresses which are occurring after redistribution, what is happening. So when we will discuss about various aspects related to tunneling, all these things will be covered in terms of its elastic analysis, elastoplastic analysis, plus the analysis for the lining. Then the next one is nuclear waste repository. You know that nuclear waste is really a prime concern for its deposition. So usually what is done is deep below the earth's crust, this is deposited. So for that, again at that level you have the rock. So we need to appropriately design this structure so that it will be able to serve for few years, like 100, 200 or 300 years. Then the next application which is there is the open cast mines. Everybody knows about it when we have to go for any kind of mining operation. So let us say if it is a rocky strata, I just cannot cut the slope with closed eyes. We need to see whether the slope at which angle that we are cutting it, whether it is stable or not. So all those things will be coming here. So it is not that it is a very new branch. You can see that from the ancient times, many structures in rock masses they have been constructed. Here this example, like this is a big temple in Tanjavur, and some others are there. I just downloaded it from the internet for your ready reference, that this is not the very recent engineering branch, but it is done for long time back. And then with the development and the various aspects related to this branch of engineering, we need to learn, we need to update ourselves so as to have better analysis and design of the structures which are founded on rocks and rock masses. So in today's lecture, we saw that how this subject is going to be helpful to us, why we should learn about it, and then what all are the various topics that we are going to discuss in this, what are the various field applications. So we will start with the different minerals, because rocks, I mentioned to you that they are composed of minerals. So we will learn few aspects related to minerals, how these are identified in the next class, followed by different types of rocks. So thank you so much. Thank you.